recording. Good afternoon, everyone. Let's see homework. I'm sorry that I posted so late. Next time I'll try to do it earlier. Let's look at the homework. I did say I'll give a couple of comments. Thing is that we have many different ways of solving most of these tasks. So, for example, first task was to get the word hero from the string we have here. So we can do it by indexing, first of all. So actually only by indexing. We can use replace, but that's not a good way to do that. So let's try. All right, print. And how can we do this? So last lesson we learned that we can index strings and get one character or slice of characters. So best way to do this is to address this string, example string 1, and we need first two letters. So I can use a colon without any numbers in front, because I will start with the beginning of the string, and then last number is never included, and we start counting from 1. So 0, 1 are indexes that we need, and 2 is the index we put here to get HE. So the last one doesn't count, so index 2 doesn't count. So in the end, output of this equation, just a second. Does everyone else hear me?
Yes.
Okay.
I can hear you fine.
All right, good. I think everything's good now. So we have this equation. So we're indexing a string. What does it return us? What data type? Yes, but what data type it is? String. So if it's a string, we can use plus sign to concatenate two strings. So we need another two letters. These are the last ones. So here you can do minus indexes, like negative indexes, to get last couple of letters, or you can use positive indexes, but you'll have to do that counting here. So what we do is we use this example string and index with -2. I remind you that -1, -2. And I need all characters till the end of the string, so I can just leave a colon here. In the end, I will get a hero from here. So you could do this by, for example, using replace and replacing this part, but it's not a good way to solve it, because you will have to do a lot of counting and writing manually. So basically we could do example string 1 dot replace and say replace LLOB like that to an empty string. We would get the same result, but it's not the best way to do this. So indexing is a better solution, but you can. And as I mentioned on the last lesson, how I check your homeworks. If it does what I needed to do, this means you did it correctly. There are different ways of solving different tasks, and it's pretty much all the time you have at least two. Yeah. Was there some question? All right. So there are always many ways to solve problems in programming. There are always better ways to do that, and there are less good ways to do that, but you will learn this with practice. So at the minute, if your program is working, this means it's done correctly. So there shouldn't be any problem. So next task was writing a code to return Jack is my name with capital Jack, with capital letter J in Jack, and all of the rest of the letters are lowercase. So this was quite easy. Example string 2. Dot, and we have method capitalize. Method capitalize changes all of the letters to lowercase and only the first letter to uppercase. So Jack is my name could be done with that. I think there's no other ways. Getting rid of stars. Yes, getting rid of stars. Whose microphone is on? I can hear myself. Yusuf, could you mute your microphone while you're not talking? Thank you. The third one, there are a couple of ways to solve this in this particular case. So we did see a strip method that accepted string as a different characters we need to strip from the beginning and the end of the string. So we could use strip with an asterisk string as an argument. And for this example, we can also use replace. So if we do example string free, replace, and then replace asterisk and swap it with an empty string, just get rid of it. So both of these ways will work fine. So strip and replace. Actually, you could also do something like that. Print, let's say, example string free and take from the first to minus first. This will work fine as well in this example. This means we are not taking index 0, so first star will be lost. And we are not taking index -1, so last star will be deleted. So this is a solution as well. But in general, strip or replace are better ways to do to solve this task, because you won't always be able to count, or maybe you will have, say, couple asterisks here and so on. Also, replace won't work normally if you'd had some stars inside the string, because strip deletes only the beginning and the end of the string, and stars in the middle will be deleted by replace only. So you need to be careful with this. Oops. Put it back. Next one, write a code to return hello, my name is Jack with capital H and capital J. I think this was one of the most difficult tasks. Well, I think there were no difficult tasks, but this was one the most difficult from those. So what can we do? First of all, we need to capitalize H. And we need to do that first, because we know that capitalize method changes all of the letters to lowercase, and if I do something with Jack first, then capital and then apply capitalize will change Jack to lowercase again. So I'll start with capitalize method. If I run this program now, I'll see that I have this string, so the only thing I'm missing is capital letter J in Jack. How can I do that? The only way to do this is a replace. So you can put dot replace and replace either lowercase j to uppercase j. I do recommend to use a longer string here. So lowercase jack to uppercase jack, just in case we would have some j letters inside the string as well. So maybe there's some other words with J and we don't want to change that J. So that's why I recommend to use substring, not just only one character. So if we do that, we will get the right answer. You could also do something like that. So you could take, for example, print example string 4 dot capitalize and take from the first character until the -1, -2, -3, -4. So we can do that. Plus the same string, example string 4, taking from -4 till the end and use capitalize on that. So it's a bit different way of solving this task. It needs you to count. So basically, if we take the previous example, it works fine. So we don't need to count letters. We just use capitalize, then replace, and everything works. If we do it this way, we would have to count how many indexes are there to get the jack out. So for this little string, it's not a big deal. If we would have some bigger strings or maybe some text inside, it could be a big problem to count indexes. So try using methods like that. Next one, write a code to return formatted string. Actually, there was a task to write a formatted string, so we would have to use either format methods or the f string with the letter F in the beginning. Someone did using concatenation. Basically, the task is done, but not the way it is asked. It is asked in here in the assignment. So what I will do, I will do a print statement with an f string inside, and if you forgot, f string is a pre-formatted string, so you can write your text and add some Python code or variables using curly brackets. So let's start. We do have hello, so I'll start with curly brackets. Say var2 dot. It can be either capitalized or title because we only have one word. It doesn't matter what you use, but I will use capitalize. Then I will go out from the curly braces, put a comma and a space because we don't have these characters here in variables, but we do have them here in the task, so I have to do it manually. Next one, my name is Jack, so I have variable 3 for that. So var3 dot. Here we can use lower because we need the lowercase letters, yeah, like that. Add the space manually after curly brackets because we do need a space here, and then I can use a var1 with the capitalized method applied. You could also use a format method and do a separate string in a variable. I won't be showing this. I think you can manage to do that on your own. But yes, strings with F letter, the formatted strings are a good instrument actually, so we can do that very easily. And also, if you wanted to save it somewhere, for example, in the result variable, you can use this f string as well. So what it does save this long string to result, and we can print it separately. So like that. And the last one was to decode the byte string. I think that was the easiest one because we only have to use one method. You already have encodings that you need to apply. So let's do it quickly. Byte string decode gets encoding as an argument, so it can put UTF-8, and I'll copy this line and change it to UTF-16. So it's lambda and some, I'm not even sure if that's hieroglyph or something like that. So different encodings encode bytes differently. So the same bytes can be represented as different characters using different encodings. Any questions? Okay. So we won't waste lots of time and start with a new topic. Today's topic is quite big and it's quite important, so let's start without any delays. We will be learning, let's say, last data types, like last basic data types today. I'm not sure if we will have enough time to get dictionaries, but we'll see. There are 4, I call them complex data types, comparing to numbers, for example, integers and floats. And there are 4 of those. Dictionary is a bit different, but list, tuple, and set have a lot of in common between them. So in this table, you can see some, let's say, main statements about these data types. If you're familiar with programming in different languages, other languages usually have an array Python has three different arrays, so it's list, tuple, and set. They behave differently. And other languages have object, while Python has a dictionary, but that's the same thing. So if you're familiar with some other programming languages like JavaScript, for example, maybe someone tried assembler back at school. These are arrays and objects. So let's see what is in common and what is different between those data types. So list is the most commonly used of those three. I'm not talking about dictionaries now. So it's list, tuple, and set. So list is the most commonly used of them three. List allows duplicate members. List is changeable. List is ordered, and it is created with square brackets. Tuple is quite similar to list, but the only difference is that tuple is not changeable. So list is changeable, tuple is not changeable. Set is a different story. Set doesn't allow duplicate members. Set doesn't allow duplicate members, and mostly used to get rid of duplicates. So if we have some similar data, I will start showing you in the code in a minute. Set cannot be changed, but can be added. So basically what this means that set is not indexed, because those two data types can be indexed the same way as a string. Set is never ordered, so all of the set elements don't have their order positions. And this is logical because it doesn't have indexes. We can't index stuff. This means we don't have any order inside. We just have some data. Set is created by curly braces. And if you pay attention here, the dictionary is created by curly braces as well. I will explain what's the difference in a while and why we can use same brackets for two different data types. So let's start with a list and then we can go to tuple and then to a set. So first things first, how can we create an empty list? Because we have empty string. String is a complex data type as well. We know that string consists of characters, and we can create an empty string. So we can create an empty list as well. I will create a variable for that. Let's call it empty list. And there are two ways to create an empty list. First is using empty square brackets, print type empty list. So first is using empty square brackets. I will use same variable. In Python, variables can be redeclared. And there is a list method. Actually, this list method is method that can be used to convert types to list. We will see conversion in a while. It is legal to redeclare variables in Python. So I declared empty list and then I redeclared empty list again. But the reason why I have a wording here is because I declared empty list and never used it and redeclared it again. So PyCharm is actually trying to say that if you don't need one of those, you can delete it. Yeah? For example, if I delete first, there won't be a problem. But if I do, let's say, print type empty list like that, PyCharm won't be showing me any warnings anymore. Why? Because I created empty list variable, I used it once, and now I use the same variable to put a new value. So it's okay for PyCharm. So empty list. Empty list is a list without any elements, and all of these data types we'll be looking today can consist of different elements. So you can think about them as some collection of elements, or if we talk in programming language, array of elements. before we continue, I want to show you that we can convert empty list to pretty much any data type apart from numbers. So if I'll try to do int from empty list, it will give me an error because list cannot be converted to float or integer. But if I convert list to string, for example, and as I told before, whatever you convert to string, you will get the same thing, but as a string. So empty list is 2 empty square brackets, and when I convert it to string, I just get a string with empty square brackets. So converting to string is easy. But you can convert it to Boolean as well. And that's the main thing. If you convert list to Boolean, it's quite similar to string. What string returns as false when we convert it to Boolean? String. What string returns false if we convert it to Boolean? There's only one string that returns false. Anyone?
0.
0 is a number. We are about strings.
Null? No, there was one.
There was only one string that returns as Boolean false. It's an empty string without characters. If we have at least one character, doesn't matter which, string converted to Boolean will always return true. So it's same with lists. If it's an empty list, it returns you false. If it has at least one element inside, it will return you true. So very, very similar. Pretty much same as it is with strings. String consists of characters. Lists consist of elements. And let's create a list with some elements inside it. So I'll call it a field list. And don't use the word list for naming variables because we have method list that is used. So field list, I will put square brackets and we'll see what can we put inside the list. So elements are separated by commas, and element data types can be pretty much anything. So you can do, let's say, an integer. I'll put 1, 2, 3. You can do a float. So let's put some floating point number. You can put a string, for example. Hello. If you have any data type in variable, let's say I'll do a variable word and put world in it. Variables can be used as well, so you can put variable, but I will be repeating myself again and again. So why can I can use variable here? Because variable has a value of string, and string can be a list element. So pretty much everywhere where you can put a string, you can put variable with a string. Can I make variable with integer or float and put it here? Of course I can, because what variable does, it only returns the value. And before I continue, I can print you a field list, and we will see that there is a value of this variable inside the list, not the variable name itself. So pretty much everywhere where you will be using variable, you will get its value instead. So you will never see this word name anywhere in output. So it goes here automatically. But what's more interesting, another list can be an element of a list. So I put another pair of square brackets here and do, let's say, 1, 2, 3, 4, 5. Non-type, of course. So as I said before, any type of data can be a list element. What can I also do inside this smaller list? 1, 2, 3, 4, 5. I can create another list, for example. Let's say 9, 9, 9, 8, and put a comma after it. So we have a list within a list within a list. And this can go as deep as you want. So you can have 100 lists inside each other. So it's legal. Okay. Another thing that list has, pretty much same as a string, list has length. So the length of the list is the number of elements you see inside. So we use the same method. It's method len. And before I run it, how many elements do you think there are in the field list? Any ideas? How many elements there are in a field list? 6. Yes, this is a correct answer. The thing is that when I check the length of the list, I check only elements inside these square brackets. So if I want a number of elements inside the field list, it's pretty much integer 1, float 2, string 3, another string that comes from variable 4. It's that list, and it doesn't matter how many elements inside this list. The whole list is only one element. So it's 5, and a non-type is 6. So the length of field list is 6. Method len returns you an integer. So we have 6 elements. I'll go to another line. And I want to remind you how we can index stuff, and you will also see that you can index elements inside the list too. So if I put square brackets after the list variable, I can do pretty much all of these things that we could do with a string. For example, I can put one number, 0, and get the first element, or I can use 1 to get second element, and so on and so on. So I can index list by element. I can take a range or slice of elements. So I want 1 to 5. I will get a list from second until fifth element, six elements included. So I can index it like that. I can also put a step and take every second element from within my range. So lists behave, but indexing lists is pretty much same as indexing strings. But there is one difference. When we index strings, we always get string in return, because string consists of characters. Each separate character is still a string. When we index lists, there are different, let's say, different data types you can get in return. For example, by indexing index 1, I get this number. This number is type float. This means that output of this equation is float. So I get a float. And if I check a type, it will say float. If I index 0, let's say, I will get int because first element is an integer, and so on and so on. So where does the difference between strings and lists come? Just a second. The difference comes when we try to get a slice. So basically, if I take 1 till 5, like 1:5. So I want to take many elements, not one element, but a couple different elements. If I do it this way, I will get another list as an output. So the basic rule is that when you take one element from list, your output is the same data type as this element. So you take integer out, you get integer in output. You take float out, you get float in output. You get string out, you get string as output. But if you take more than one element from the list, you always get list in return. So in this case, I have another list that doesn't have integer and doesn't have none. So when you slice, when you have start and end, you always get list, even if it is like that. So basically what I did, I took just one element from 1 till 2. 2 is not included. I get only one element, but it's a list with one element. So you have these square brackets and a float inside. So this is a thing for you to remember. All right. Now, I'll do another print statement and try to get this list from here. And the thing is, for example, you have this complex list as this one, as this field list, and you need to get, let's say, number 8 from here. So we have a list within a list within another list. So it's quite complex. And for example, you need to get this number 8, just this number. So how can you do this? First of all, you index elements within the main list. Let's say for us, main list is a variable field list. So I take field list and index this element. So it's 0, 1, 2, 3, 4. 4. What data type I get as an output? Any ideas?
List.
List, that's right. So I get the list. What did I tell you before? If you have an output that is some particular data type, you can work with this output like you would work with this data type. So if this is a list, that equation is a list, this means I can index it as well. So what I do, I put another pair of square brackets and say that I want to take second element. And the second element from this list, from the list we have here in output. So it's 0, 1, 2. And by that, we should get this small list with 3 9s and 1 8 inside. So that's what we do. So if I want 8, I need to index all of this equation one more time. Because field list with square brackets 4, square brackets 2 returns us list again. So I can use it and I can put another pair of brackets, either 3 or -1, last element. So it's up to you. And only now I get an integer. So all of this indexing from list returns us an integer in the end. And just because it is an integer, I can do something with it. Like I would do with an integer. So I can't, for example, add string to it. Why? Because you can't add string to an integer. But I can, but what I can do, I can, for example, add some numbers to it or whatever. So this is the way of indexing lists, and actually it will be exactly the same with tuples. The difference between list and tuple is that tuple is not changeable or immutable. Okay, now let's look at a couple of different methods we can use to work with lists. For that, I will create a new list. So I will comment all of this out. And create a new list, and I will name it courses. I will come back to mixed lists and lists with the same data type for each element, but for now I will use only string elements inside. And courses will have a couple of different subjects. Let's say history, math, I'll do literature. Let's do a couple of more. Let's add physics and programming. I'll do another list below. I'll do a list nums or numbers. Let's do numbers. And I will add, please repeat after me, 1, 5, 6, 8, 3, 4, 2. Well, actually, it doesn't matter how I do this, but let's do it this way. I will come back to this table I had before. So, list allows duplicate members. We already saw that when I created a list with 3 9s inside. It's not a big deal. It's not a problem. You can even have list with like 100 same elements inside if you need it at some point. So lists allow duplicates. Now let's see. Okay, lists are ordered. How do we know this? Each element has its own index, so there is an order, and each index return these. Each time we use some index, it will return same element all the time. So if I index 2 and do it 100 times, I will get same element. Nothing will change. So lists have order. Let's speak about how lists are changeable. By saying changeable in this table, this means that you can address a list's index. For example, you can say, let's print courses first of all, print courses, and then I will address courses, let's say 1. So what makes element changeable? This means that we can address some index and give it some new value. And I'll print courses again after that. So what happened here? We had a courses list that had history, that had math on index 1. So second element was math. And what I did here, instead of creating variable, I addressed first index, then I put an equal sign. In Python, it is an assignment operator. It doesn't have anything in common with equals in regular math. I already told you before that, for example, a equals 5, a equals a plus 10 is legal. So left side and right side don't have to be equal. Equal sign doesn't check equality. Equal sign is an assignment operator. That means I have a equal to 5 here, and in the next line I say that new value for a is a's old value plus 10. So new a is 15 now. Print a, new a is 15. So what I do here, I index one of the elements and say that it will have a new value now. And if we will look at the output, we'll see that in the first list, in the first printing of courses, we do the same variable actually. We have math on this place, and in second print we already have art. So compared to strings, lists are changeable. Remember, the only way we could change the string is by giving it a new value. Here I can change elements of the string. And to check this, I can show you one thing. There is a method called id in Python. You won't need it very often, but it will help you understand, is it the same elements as it was before, or it's a new one. So what id method does, it basically when you create a variable or you create a function or something in Python, it is assigned with a unique id number. So basically our courses variable received a unique number, and you can see it below. after we changed math to art, from Python's point of view, this unique number didn't change. So we still have the same unique number for this variable. It is different with strings. For example, I say that a is equals to hello, print id a, and then I will say that a is equals to world now, or even let's say like that, a plus world, and print id a. So when we do pretty much same thing with strings, we see that we have a different ID. This is because strings are not changeable. So all the time you do something with a string, you get a new string instead. Old string is deleted and the new string is put on its place. It's same with integers, same with floats. They're not changeable as well. But if we speak about lists, lists are changeable. So this means it's still the same list and you can make some changes in it. The reason for that is, actually I will explain it a bit later when we'll see the method. Do you have any questions at this point? Okay, I'll comment these out. And now we can see some list methods. Compared to strings, lists are changeable. This means that using methods with lists will change the original. Remember, every time we used methods with string, original was the same. We only got a new string, like edited string, as a result, but original was never changed. With list, it's a different thing, and there are plenty of different methods that you can use to change your lists. First of all, when I showed you string methods, I always used print. And for example, okay, I won't be doing it now, but I used print. The reason I used print was that string methods get new value themselves and return it. So every time I use, for example, hello dot upper, method upper takes the result and returns it. So this means that whole equation I use here is equals to the upper string hello. And I can print it because the result is string. When we speak about list methods, they behave differently. So we have method append. Method append adds something to a list. So if I do it this way, I will stay inside print courses dot append, and let's say we want to append art. I want to add art into our list. And if I run this program, in the console output, I will see none. Where does this num come from? Before I'll start explaining, I will print original courses as well. So we want to see what happened. If you look at the printouts in the console, you can see that art was added to courses. So we changed courses to have one more element, that is art, and append method always adds to the end of list. So method append always creates a new index for an element. But why did we get this none? We get this none because of this line. This method courses.append never gets any value. So this method's value is none. The only reason we need this method for is to add something to a list. This means that we don't have to print this method because its value is always none. We can use it without a print statement to change the original. So some methods return value, some methods doesn't return value, and most of the list methods never return values. String methods always return value. And we will speak about that more when we will be looking at functions, because pretty much methods are functions inside classes. And when we will be talking about functions, I will show you how we can create a function that returns a value and a function that doesn't return anything, or basically returns none. So append. Append always adds value to the end of the list, for the last index. And the reason for that is that we don't want to mess with our indexes. So if I use, for example, index 1, and I use method append, courses 1, and I use the append method, after append method, index 1 will still be index 1. It will still be math, because we only added a new index here. We didn't change anything inside. This is why method append only adds to the end of the list. By using append method, we can add only one value, only one element. So if I think that I might be wanting to add a couple of elements and make a list of them, let's say English, append art and English, and print this out, you will see that method append took the list as a single element and added it to the end of the list courses. So a method append only take one argument, and this element will be added as a single element. So we have another pair of square brackets, and we see that last element of courses is a list consisting of two different strings. There is another method for that. I will delete those. One thing I wanted to show you, indexing lists is same as strings. You are not allowed to index non-existing elements. So if I say, for example, courses 10, I will get an error, index error, list index out of range. So we're not allowed to index elements that doesn't exist. This is one of the things. So append adds something to the end of the list. This is the mostly used method while working with lists. So you want to add something. By using append, you don't create new lists, but you update yours. And if we try, let's say, print ID courses here, and then I'll do print ID courses at the bottom after using method append, it's still the same ID. So it is same element, it wasn't changed. And append only adds something to our existing element. So this is the main difference between strings and lists. If you want to insert a value to a specific place, so you don't want to add it to the end of the list, maybe you want to add it to first place, for example, or second, or something like that. There is another method for that, and this method is insert. Insert method allows you to put values wherever you want. And for that, if you look at the snippet, you see that we have index that must be an integer, and we have an object. Object is basically a value you want to add, so any data type you want to add to a list. So let's say I want to add it to the first position, and I will add English. Let's put English in here. Insert. So I inserted to position 1, and I can see that 0, 1. English is now on index 1. Rest of the list elements are not deleted, or they are just moved one position ahead. And that can be a big problem, because if I do print courses 2 here, and I do print courses 2 after I inserted an element, I see that it is two different elements. So by inserting something to position 1, I made other elements as indexes to be incremented by 1. So this means that before insertion it was literature, but after insertion everything moved one step and I have math on this place already. So this is why I do recommend you to use append instead of using insert. Use insert only when you understand what you do and this is what you want to achieve. Otherwise, you might get problems with indexing later because indexes are changed and we don't actually want to change any indexes if we later on use them. So insert can put data to any place, but it moves indexes to the right of it. So you need to be careful. Because if we speak about 0 and 0 here, it didn't change. It is still the same. Why is that? Because we inserted English here. So nothing on the left side is changed, but everything on the right side is increased by 1. Method insert adds one element at a time, same as append method. So if I put a list of elements here, it will be added as a single element as a list, same as I showed you before with append method. So how can I add more than one element? I will comment these out and use courses.extend. Courses.extend is another method to add elements inside to the list, and courses.extend takes an iterable, as you see, as an argument. I won't be talking a lot about iterables now, but what you need to understand, iterable is any element that consists of other elements. So what iterables we know now, it's string and list for now. I will go, let's say, I will go a little bit further and say that tuple, set, and dictionary are iterables as well. So they consist of smaller elements. Is number an iterable? We can say yes. For example, number like that. Extend, can't leave empty extend. So it is a number. It consists of digits. So we can think of it as an iterable, but it's not actually right because this element doesn't have a len method. Numbers like integers and floats cannot be, their length cannot be measured. They don't have any length. The only way I can measure length of this input is by creating a string of it. So string does have characters. So we do have elements. So later on, you can check for yourself if item has a length method. So you can check the length of the item. This means this item is iterable. So it consists of other elements, whether it's characters like string or whole large elements like lists. They have different elements. So extend. Extend takes an iterable as an argument. So as I told before, we can use either string or lists. If I take a string, let's say I put art in here, I will get a weird result in the end. So basically what happened? Method extend takes all separate elements of an iterable and adds them one by one to the end of our list. So what happened here? String consists of characters, and extend method took every single character and added it to the end of the string or list. ART. So it's not what we wanted to. We wanted to add elements. So what I can do, I can use list as an iterable. And let's say I will add art in English. So speaking about lists, lists consist of elements, not characters. So each element can be a complex data type itself. So what method extend does, it takes each element of the list and appends it to the end of our list. This way we can add many items at a time. So it's a bit different. So basic rule is try using append every time you want to add one element, or using extend if you want to add several elements. Insert can be used also, but there is a problem that indexes change. So try not to use insert if you don't need it. Any questions so far? Okay, so if we can add something to a list, this means we need to have ways to remove something from the list. And we can do this in two different ways. First is a remove method, courses.remove. Remove does accept one argument, and snippet says it's a value. So basically how remove method works, it deletes value you type inside these brackets. For example, if I do math here, so I need an exact copy of an element here. So math will be deleted from our list. So if you want to delete math, you need to give this value here. If you do a mistake, for example, do maths or math, you will get an error because remove method didn't find this element in the list. It actually same. It is same if you have, for example, 1, 2, 3. You have, for example, you have a list there, not a string. So in order to delete this list, I need to provide this list here inside remove method. So that will work. If I don't provide this list or do it in some wrong way, let's say I say it's a string of a list, then you still get error because this element, string with this list, doesn't exist here. So be careful with that. So remove method does remove element by value. So you have to provide a value. Second thing, if I save this to a variable and try to print it, the remove method doesn't remember the value you deleted. So if you want to save this value somehow, it is not possible to do that with remove, but you should have this value already. So if you try to delete by some value, you need to provide it. This means you already have it. If you don't have it, you can't use remove method because you don't know what you are deleting. So this is the thing about method remove. I'll delete this variable here. But if you want to delete something and remember it, there is another way. I will do, let's say, variable removed. We'll call it removed. And use a courses.pop without any arguments for now. Courses.pop. And let's say print removed as well. I got English, and the reason for that is that we added art and English to our list, and English was the last element. At the time, I wanted to remove something. The pop method always removes last element in the list. So at that time, it was English. If I delete this list and I comment out everything but pop like that and run, it will be programming because we didn't add anything to our list and method pop did take the last element, so programming. The thing is that programming was deleted from original, we don't have it here, but method pop returns the value of a deleted element. This means that if we want, we can save it to variable and use this element later on outside of our list. So we remove it from list, and also we can save it for later if we want. This is pop without any arguments. So you don't put anything inside the brackets, you get the last element from the list. So list element is deleted, or if you want, can be saved in a variable. Pop accepts argument. This argument is integer and it resembles an index. So if I want to delete some special element, let's say second, so 0, 1, 2, I can do that as well. So using method pop with lists allows you to select index you want to delete. So I chose index 2. It resembles literature. Literature was deleted from original list and it was saved to a removed variable. So two ways of deleting element. Remove, that needs you to provide a value you want to remove and will give you error if this value doesn't exist. Or pop method that deletes the last element or element which index you put inside the bracket. We can also try to put index that doesn't exist, for example 10. We will get index error, pretty much same as normally indexing non-existing elements. So index 10 doesn't exist, we get an index error, and we have this pop index out of range here. So be careful with those. You can't remove something that doesn't exist. And that's actually a thing I like about Python, because Python does give you error in like situations like this. If you compare it to, let's say, JavaScript will still continue working. It won't give you error. It will do something. For example, get an empty space. And in JavaScript, you can create a list that has, for example, first and second elements, 9 empty spaces, and then 12th element. So it is not possible in Python. Each element's place must have some variable. Actually, what do you think will happen if we leave an empty string in here, for example? Can we do that or no?
I think we can.
Yes, because empty string is still a data type. It's still an element. It's an empty string, but it exists. So we can use it pretty much same as we can use none. So this is methods for deleting things from lists. Any questions so far? Okay. Comment this out. Do it like that. Remove. Okay, so what we learned so far, we learned that we can have an empty list, we can have a list with elements. List does have length. Length resembles number of elements inside list. List can be indexed same way as we could index strings. And we looked at methods append, insert, and extend, and methods remove and pop. Now we will look at a couple of methods that can modify your lists. So first method is courses method reverse. So courses reverse doesn't return us anything. Courses reverse changes original list to be a reversed one. So basically what we get here is we get the same list, but elements are done right to left. So you can actually get the same result, same way I showed you with strings. It's colon -1. You get the same result as well. Just comment the reverse because this line reverses it back. But the difference is that courses reverse does change the original, and indexing courses like that doesn't. So this line returns you a copy of reversed list. And this line, courses reverse, does reverse you an original. So it depends on what you want to achieve. You can use either reverse methods or you can use this indexing. So if you don't want to change the original, you want to just to get a reversed copy, you can use these brackets, 2 columns and -1. If you want to reverse original and save the changes, you can use the reverse method because lists are changeable. You can also sort elements, courses.sort. And if you look at the snippets there, you can see a key and reverse arguments. I'm not talking about key argument because key argument needs you to insert a function, and we will look at functions in one lesson, I think. Not next one, the one after. So I will come back to functions a bit later. But what does method sort do? It does sort you values inside the list. And you need to be careful with the sort method. The reason for that is in order to sort something, sort method starts comparing elements. And what does this mean for us? For example, I have a number here, like that, integer. I will get an error using method sort, because you cannot compare integers and strings. These are different data types. They cannot be compared between each other. So method sort will work in lists where you have all similar elements, because method sort can work with numbers, for example, as well. If I use here, let's do it at the bottom, numbers.sort, print numbers, you will see that we can sort number lists as well. But if I get any strings inside here, even if it's a, let's say, string with numbers in it, it's still different data type and it still will cause error. So be careful. Using sort works only with lists with the same data type elements, because one of the steps to sort a list is comparing elements between each other. Second thing, you need to understand this upper lowercase comparison too. Remember, I showed you Unicode character table last lesson, and I told you, remember the thing that numbers first, then capital letters, then lowercase letters. So if you look here, we have all of the courses with capital letters, and it's easy to sort them. But what if I will have some lowercase letters, for example, art or English, or maybe I even have some numbered strings? So what should I do now? Yeah, how will sort method work? So if I do that, I can see the same logic we had in this table. That's what I told you before. So lowest first and the highest later. We know that we have this Unicode character table where each symbol has its own position, like number or order. And when we compare letters, these positions, these numbers are compared. So numbers first, then we have capital letters, and then we have lowercase letters. So sorting logic is not actually 100% alphabetical. It depends on the case as well. Because if you look at, let's say, uppercase part, you see, yes, it's in alphabetical order from A to Z. It's same here for lower cases. But comparing uppercase to lowercase is a different thing. So that's why we have all sorted numbers, then all sorted uppercase strings, and then all sorted lowercase strings. So you need to consider that while sorting as well. If you want a reverse order, So you want to sort from the most to least, from Z to A, from 9 to 0. You can use an argument reverse and give it a value equal to true. So it will be sorting in a reversed order. So we will get pretty much everything backwards. Yeah, but be careful with sorting. Only works in lists with the same data type. So you can get errors by sorting irregular lists while you have mixed data types. Okay, sort. We will come back to key argument later on in the course when we will finish with functions. So you need to know how functions work, and we can use this key with a function later on. Next thing, there are a couple, I call them statistical methods. Statistical methods can be used with iterables, so not only with lists, but with strings, for example, as well. These are min for minimum. Let's take numbers for now. Print max numbers, or for example, sum numbers. So what it does, min and max give you the minimum and maximum value from the list. So element with the maximum minimum value. Just because I use the numbers list, I get 1 and 8. So 1 is the lowest, 8 is the highest. So minimum, maximum. Sum pretty much speaks for itself. So sum sums all of the numbers inside the list. But what will happen if I use courses instead of numbers? Because we do have strings in courses and not numbers. I will get an error. Error is caused by sum because we cannot sum strings. Easy. I will comment this out and leave min and max. But min and max will work great. So the minimum value in my courses list is 1231 here, and the maximum value is English with lowercase e. So what happens here, to get the minimum and maximum value, Python will still be comparing values. So it will be comparing values using the same Unicode table, and when we get the lowest, these are usually numbers, and the highest is usually lowercase letters. So this will work, minimum and maximum will work with strings as well. So min and max. Any questions so far? What I offer to do? I actually offer you to do a break for now. Are you okay with that? Online? Are you okay with the break now?
Yes.
Yes.
Okay, I'll stop the recording then.